Now in this one we will be covering sequential access collections. Let me tell you that this is going to be theoretical, as most of the topics that we'll be explaining over here will be covered in upcoming lectures as code examples. So to start with, sequential access collection is basically a list that stores its elements in sequential order. We call this type of collection a linear list. Linear lists are not limited by size when they are created, meaning they are able to expand and contract dynamically. Items in a linear list are not accessed directly. They are referenced by their position. So the first element of a linear list is, let's say, at the front of the list, and the last element is at the rear of the list. Because there is no direct access to the elements of a linear list, to access an element, you have to traverse through the list until you arrive at the position of the element you are looking for. Linear list implementations usually allow two methods for traversing a list: in one direction from front to rear, and from both front to rear and rear to front. We can take an example of to-do list items, let's say. So the list is created by writing down one item after the other until the list is complete. Now the items are removed from the list while each item is completed or finished. So the linear list can be either ordered or unordered. An ordered list has values in order in respect to each other, as in John, Jessica, Frank, Miller. An unordered list consists of elements in any order. The order of a list makes a big difference when performing search data on the list. And this is something which we will be coming up when we'll be exploring searches or search algorithms. Now there are some types of linear lists which restrict access to their data elements. Examples of these types of lists are stacks and queues. A stack is a list where access is restricted to the beginning or top of the list. Items are placed on the list at the top and can only be removed from the bottom. For this reason, stacks are known as last in, first out structures. When we add an item to a stack, we call the operation a push, and when we remove an item from a stack, we call that operation a pop. Stack is a very common data structure, especially in computer systems programming. Stacks are used for arithmetic expression evaluation and for balancing symbols among its many applications. Now we have queues as well. So a queue is a list where items are added at the rear of the list and removed from the front of the list. Now this type of lists is known as first in, first out structure. Adding an item to a queue is called in queue, and removing an item from a queue is called a dequeue. Queues are used in both systems programming for scheduling operations, system tasks, and for simulation studies. A special type of queue called a priority queue allows the item in a queue with the highest priority to be removed from the queue first. Priority queues can be used to study the operations of a hospital emergency room where patients with heart trouble needs to be attended to before a patient with a broken arm, for example. Now the last category of linear collections are indexed collections. The first of these called a hash table, and that's what we will be covering in upcoming lectures. Now hash tables stores a set of data, values associated with a key. In a hash table, a special function called a hash function takes one data value and transforms the value called a key into an integer index that is used to retrieve the data. The index is then used to access the data record associated with the key. For example, an employee record may consist of a person's name, his or her salary, the number of years the employee has been with the company, and the department he or she works in. So the key to this data record is the employee's name. We have classes in C# which are called hash tables for storing data in a hash table, and this also will be covering in later videos. Similar to hash tables, we have another collection that is called as dictionary, which is made up of a series of key value pairs called associations. Now this structure is analogous to a word dictionary, where a word is the key and the word's definition is the value associated with the key. The key is an index into the value associated with the key. Dictionaries are often called associative arrays because of this indexing scheme. though the index does not have to be an integer. We'll be also covering dictionaries in upcoming videos.